Hi guys, today I'm going to show you how to factor polynomials. If we want to factor a polynomial, what we do is to find the greatest common factor of all terms in the polynomial. The greatest common factor is the value that can be divided into each term of the polynomial. Let's look at some examples together. If the polynomial is something like 4x plus 2, the greatest factor that can be divided into both terms here is 2. Then we factor out the 2 to get 2 times the 2x plus 1. Okay, how about this one? X cubed plus x squared plus x. We can see that each term has the same letter. If so, the lowest degree letter will be the greatest common factor of the polynomial. In this case, it will be x. Then let's factor out x. We get x times the quantity of x squared plus x plus 1. Still not a big deal, right? Okay, let's try a little more complicated one, like this example. 3 times the quantity of x plus y cubed plus 5 times the quantity of x plus y squared. We can treat the quantity of x plus y as one unit. Then the lowest degree of this unit will be the greatest factor that can divide into both terms. In this case, that will be the quantity of x plus y squared. We factor it out and get the quantity of x plus y squared times the quantity of 3 times the quantity of x plus y plus 5. We don't normally leave it this way. We will get rid of the inner bracket and simplify it to the quantity of x plus y squared times the quantity of 3x plus 3y plus 5. For the last 3 examples, we just need to factor out the number part or the variable part. Quite often, we must factor both. Take this one for example. 4x cubed plus 8x squared plus 8x. If we just factor out the number part with the greatest common factor of the numbers, we get 4 times the quantity of x cubed plus 2x squared plus 2x. Do we factor out every common factor each term has? Apparently not, because we can see that x is the common factor of each term as well. So, we should also factor out x. That means we should factor out 4x, not just 4. Then we get 4x times the quantity of x squared plus 2x plus 2. That is the correct answer we are looking for. There is one more thing I want to show you about factoring polynomials. That is, if the highest degree term is a negative term, like this example, negative 2x squared plus 3x. Then besides factoring out the greatest common factor of the number part and the variable part, we will need to factor out the negative sign as well. So the greatest common factor will be negative x. Then we get negative x times the quantity of 2x minus 3. That is the simplified result. Be careful when you factor out the negative sign, because the signs in front of each term need to be flipped. The 5 examples above are basic methods to factor polynomials. I'm going to show you another method of factoring called the formula method. There are 2 different formulas used in factorization. One is the difference of squares, and the other is the perfect square formula. Don't panic if you have never heard of them. They are not as difficult as they sound. The formula difference of squares is a squared minus b squared equals the quantity of a plus b times the quantity of a minus b. It means that the difference between the square of 2 numbers equals the product of the sum of the 2 numbers and the difference of them. Let's try this method in some examples. X squared minus 4. 4 is the square of 2, so we can directly apply the square difference formula directly. X squared minus 4 equals the quantity of x plus 2 times the quantity of x minus 2. Let's look at another example. 2x squared minus 18. At first glance, it seems the formula of the difference of squares cannot be applied to this because 18 is not the square of an integer. But if we look closer, we will see they have a common factor 2. We can factor out the 2 and get 2 times the quantity of x squared minus 9. Aha! Now we have a 9 here, which is the square of 3. Then we can apply the formula of the difference of squares and get 2 times the quantity of x plus 3 times the quantity of x minus 3. You see, when factoring, we first decide if there is a common factor in each term. If there is, factor out the common factor, then apply other methods later. Next, I'm going to show you the two forms of the perfect square formula and how to use them in factoring. The first form of the perfect square formula is a squared plus 2ab plus b squared equals the quantity of a plus b squared. Let's try this formula out with some examples, like this. X squared plus 6x plus 9. Here 9 is the square of 3. 6x equals 2 times 3x. Apply the perfect square formula to it. We get x squared plus 6x plus 9 equals the quantity of x plus 3 squared. Let's look at a more complicated example. 5x squared plus 10x plus 5. How do we factor this? We first factor out the common factor 5. Then we get 5 times the quantity of x squared plus 2x plus 1. Obviously, we can apply the perfect square formula to factor x squared plus 2x plus 1 into the quantity of x plus 1 squared. So the result is 5 times the quantity of x plus 1 squared. Another form of the perfect square is a squared minus 2ab plus b squared equals the quantity of a minus b squared. It means the difference of two squared numbers minus 2 times of their product equal the square of their difference. Keep in mind that 2ab here is a negative term. In the first form, 2ab is a positive term. We must look at the sign before 2ab, then decide which formula we can use. Let's try out some examples with this formula. X squared minus 8x plus 16. 16 is the square of 4. 8x equals 2 times 4 times x. So we can directly apply the perfect square formula to get the result. The quantity of x minus 4 squared. Okay, let's try one more complicated example. 2x squared minus 8x plus 8. First factor out the common factor 2. 2 times the quantity of x squared minus 4x plus 4. 4 is the square of 2. Negative 4x equals negative 2 times x. Because it is a negative term, the result is 2 times the quantity of x minus 2 squared. It's easy, right? Practice makes perfect. Previously, we learned two methods of factoring polynomials. One is factoring out of the common factors. The other is using the difference of square formula and perfect square formula. Some of you might wonder, what if some polynomials are just not able to use either of these two methods? Well, that happens. That is why I'm going to show you a different method today, called the crossing method. It is an excellent method to factor the kind of polynomials like ax squared plus bx plus c. A, b, c. Here are all integers. Factoring this type is a little different according to the value of a. If a equals 1, that means we get x squared plus bx plus c. Let's look at this example. X squared plus 5x plus 4. Rewrite a cross first. X squared is the product of x and x. Then write two x's on the left side of the cross. What numbers should we write on the right side? The product of these two numbers should be 4. Here, the 4 can be the product of 2 and 2, -2 and -2, -1 and -4, or 1 and 4. Then we get the product. This pair, x times 2 is 2x. This pair as well, x times 2 is 2x. We add 2x and 2x together, we get 4x. 4x is not equal to 5x, so this way doesn't work. We do the same thing for the left. -2 and -2, -1 and -4, and 1 and 4. It is obvious that only 1 and 4 can bring us 5x, so 1 and 4 are the integers we are looking for. Then we can factor the polynomials into the quantity of x plus 1 times the quantity of x plus 4. But what if b is a negative number? Are we still able to do it in the same way? Sure, we can. Let's look at this one. X squared minus 4x plus 3. Here the 3 can be the product of 1 and 3, -1 and -3. Which pair are we going to choose? Yep, the pair that the addition is going to bring us the -4x, that is, -1 and -3. That means we can factor the polynomial into the quantity of x minus 1 times the quantity of x minus 3. Now let's talk about when a is not equal to 1. The idea of solving this kind of problem is still similar. Let's try this one together. 2x squared plus 7x plus 6. In this situation, we must pay attention because the left side of the cross is not x and x anymore, but x and 2x instead. Here 6 can be the product of 1 and 6, 2 and 3, -1 and -6, -2 and -3. Let's cross multiply them. Only the pair 2 and 3 will bring us 7x. So we can factor the polynomial into the quantity of x plus 2 times the quantity of 2x plus 3. That's the result. That is the cross method for factoring. We already talked about several methods to factor polynomials. Using the crossing method seems to need more skills than others. But don't worry. Today we are just going to practice on some more exercises together so that you will understand this method better. Let's look at the first exercise. X squared minus 2x minus 15. Here, -15 can be the product of 1 and -15, -1 and 15, 3 and -5, -3 and 5. When using the crossing method, the result of 1x plus -15x is -14x. The result of -x plus 15x is 14x. The result of 3x plus -5x is -2x. The result of -3x plus 5x is 2x. So only the pair of 3 and -5 brings us the result that we want. Then we get the quantity of x plus 3 times the quantity of x minus 5. Let's look at another one. 3x squared minus 18x minus 21. Keep in mind that if there is a common factor, we must first factor out the common factor before we apply the crossing method. Like this one, we must factor out 3 first, rewrite the polynomial into 3 times the quantity of x squared minus 6x minus 7. Now we can apply the crossing method. Here the -7 can be the product of 1 and -7, -1 and 7. Applying the crossing method, the pair of 1 and -7 brings us the result -6x. We must not forget to bring the 3 along for the result. It will be 3 times the quantity of x plus 1 times x minus 7. Now, let's move on to the next one. 2x squared plus 7x plus 3. Here the coefficient of x is not 1. Pay attention, because the left side of the cross is x and 2x, not x and x anymore. Here the 3 can be the product of 1 and 3, negative 1 and negative 3. Do the calculations by using the crossing method. The pair of 1 and 3 will bring us the result 7x. We'll get the quantity of 2x plus 1 times the quantity of x plus 3. Here is the last example for today. 4x quad plus 2x cubed minus 6x squared. This one seems a bit difficult at the first glimpse, but if we just follow all the steps we have been talking about, it will be okay. First, decide if there are any common factors. If yes, factor it out. So, is there any common factor in this one? Yes, 2 and x squared are the common factors here. Factoring them out, we get 2x squared times the quantity of 2x squared plus x minus 3. Then we apply the crossing method. Here, the negative 3 can be the product of 1 and negative 3. Negative 1 and 3. Do the calculation by using the crossing method. The pair of negative 1 and 3 will bring us the result x. Don't forget to bring the common factor 2x squared along for the final result, and it is 2x squared times the quantity of x minus 1 times the quantity of 2x plus 3. The exercises we talked about today will give you a good understanding of the crossing method. By now, we have learned 3 basic methods of how to factor polynomials. But you may notice that very often polynomials have more than 3 terms, and none of the methods we learned is going to work for them. That is why we are going to talk about a new method called regrouping today. As usual, we are going to learn this method by using hands-on exercises. Let's look at the first exercise. X cubed minus 2x squared plus 2x minus 4. This has 4 items and does look more complicated compared to the ones we have talked about before. That is why we are using a regrouping method. For this one, we will put the first 2 items in a group and the last 2 in another group. We regroup them like this. The quantity of x cubed minus 2x squared plus the quantity of 2x minus 4. Now these 2 groups look familiar. We can see that in the first group, x squared is the common factor, and 2 is the common factor of the second group. Factor them out, we get x squared times the quantity of x minus 2 plus 2 times the quantity of x minus 2. Aha! That is easy. Is that the result? No. Because now, the 2 new items have a common factor, x minus 2. We must factor it out. Then we get the quantity of x minus 2 times the quantity of x squared plus 2. Remember, we normally put them with the highest power in front. Rearrange the items, we get the quantity of x squared plus 2 times the quantity of x minus 2. Isn't it an amazing method? Regrouping definitely makes factoring much simpler. Let's use this magical method to factor this. X cubed minus x squared minus 4x plus 4. Like the last example, we regroup them into 2 groups. Then we get the quantity of x cubed minus x squared minus the quantity of 4x minus 4. Just be careful when you take the minus sign out of the parentheses. The sign in front of each item in the parentheses will need to change. That means it is 4x minus 4, not minus 4x plus 4. Now, it is easy for us to factor this. X squared is the common factor of the first group, and 4 is the common factor of the second group. Factor them out, we get x squared times the quantity of x minus 1 minus 4 times the quantity of x minus 1. The thing is, a new common factor just shows up. That is x minus 1. We must factor that out. Then we get the quantity of x squared minus 4 times the quantity of x minus 1. Is it the result we are looking for? Nope. Recall back what we learned before. The first term, x squared minus 4, is perfect to use the difference of the square formula because 4 is the square of 2. So the final result should be the quantity of x plus 2 times the quantity of x minus 2 times the quantity of x minus 1. By using these two examples, we simply regroup the polynomial with the first two items in a group and the last two in another group. But that is not always the case. We might find some polynomials are like this: a squared minus ac minus b squared plus bc. If we just regroup the first two and the last two items together, we get a times the quantity of a minus c minus b times the quantity of b minus c. We won't get any new common factors after this. But if we regroup them in a different way, like the first and the third items together and the second and the fourth items together, then what do we have? We have the quantity of a squared minus b squared minus the quantity of ac minus bc. Now it looks like something we can factor out more. For the first group, we apply the difference of square formula. For the second group, we factor c out. Rewrite the polynomial into the quantity of a plus b times the quantity of a minus b minus c times the quantity of a minus b. Then we get a new common factor, a minus b. Factor it out, we get the quantity of a minus b times the quantity of a plus b minus c. If you want to learn more, subscribe to our channel. And don't forget to click the bell to turn on notifications, so when we answer your question in our future video, you'll be notified.